breaks down, we need to iterate back to step 1, wherein we need to investigate a new region. So here since it's 85 and 90, we can choose a time of 80 and 90 minutes to encompass these data points. No? And for temperature, we can use 170 and 180 degrees Fahrenheit. Okay, so that is now our new region for investigation where we try to create a new model. So let me pull out the Excel file. So when we did this, so we have now our 80 is our low setting for time, 90 is our high setting. Low setting for temperature is 170 and high setting is 180. Then we had our center point runs. So this is my factorial runs, this is my center point runs. Okay. Now, when we did the lack of fit in class, we noticed that there indeed was a lack of fit in the model, and so we proceeded with CCD, which is the discussion point in this video. So we are now ready to calculate our start point settings, your natural settings. So let's just fill this up. So we add 4 more rows here, which will be our additional start point settings. So we have 1.414, this is our alpha value. 1.414, we have 1.414 and negative 1.414. And this will be 0, 0, 0, and 0. So again, this is just our coded start point settings. So we have to compute the natural settings using the formula I showed earlier in the previous part 1 video. So we have this is equal to your x value or the coded value multiplied by your high point setting. So for time, the high point setting is 90 minus the center point setting, which is 85, plus your center point setting. Should give you 92.7. I can drag it down. Now here it's coded value. Now this is for x2 now, the second factor temperature, multiplied by uh, high point setting is 180 minus your center point is 175 plus center point is 175. So I can drag this down again. So I should get something that looks like this. So after getting your start point settings, you need now to do the experiment itself. So suppose that we actually did the experiment now. So I'll just pull out the slides. Uh, wait a minute, class. Alright, so for example, we did the experiment. Now we already did the factorial experiment, so no need to do this. We already also did the center point setting, so we only need to do 4 additional settings, which are this coded or this start point settings here. So suppose that these are our new values now. So I'll just copy this. So this is what we got from our experiment to the Excel file. And make sure it's correct. So it's 1.414 negative 1.414, 1.44 negative 1.00. So it's the same now. Okay. So now we have completed our data table for CCD analysis. Now we need to compute um, the second order model. To compute the second order model, we should get an equation that looks like this. So this is the second order model, and if you look at it, the equation is of the second order, and you can see the pattern. So it's b0 plus b1 x1 plus b2 x2 plus b11 x1 squared plus b22 x2 squared plus b12 x1 x2. So let's say for example we added a third factor, then we should have b3 x3, and we should have also b33 x3 squared, and for the interactions we have b13 x1 x3 and b23 x2 x3. So but I think for this course we will only limit ourselves to uh, two factors, no? Pero depende din kay Sir Roderick, baka biglang mag three factors, no? So just try to look at the pattern, okay? So pero for this video lecture I'll be showing you two factors only. Okay, so to solve these different constants on the b constants, the b naught, b1s and b2s, we use this formula. Okay, so let me just copy each of this formula. Okay, I'll copy it to my Excel file here. Now let's rearrange it. So where's my b1 to have? Okay, so let's start off with the simple ones. I'll just write b naught, b1, b2, b11, b22, b12. Okay. So the first one is b1. So let's start off with these top three equations now. So b1 is just the summation of the product of x1 and y. So we can compute it by typing sum product ng x1 take note class that all of these x's here are the coded values, not the natural settings. Okay, so sum product of x1y, then for b2 it's the sum product of x2 and y. Okay, divided by 8, I'm sorry. So there should be a divided by 8 in the formula. So that's divided by 8. Also this one is divided by 8. Okay, just insert. I'll move this to the right para di magulo, no? So last one, for the simple equations is your b12. b12 is just equal to x1, x2, and y. So that's sum product ng x1. So we can choose the coded values x2 and y. Okay, and that's divided by 4. Okay, so we have, that looks about right now. Okay, so next we compute these three equations. So this is actually a set of equations. This is three equations, three unknowns, and just like our multiple linear regression analysis, we converted this into matrix form so that we can solve it easier now. So it should be in the form A times B is equal to Y. Okay, so first let's fill in the A matrix. So the A matrix is just the coefficients of all of these equations on the left side. So that's N, then we have N, then we have 8, 8, 8, 12, 4, 8, 4, and 12. So take note again that the A matrix is symmetrical around the diagonal. So 8 is equal to 8, 8 is also equal to 8, and 4 is equal to